people. Happy Monday. Today we are talking about logarithms today. Day 2 of logarithms. Day 1 of logarithms we were converting from logarithmic to exponential form and exponential to logarithmic form, so converting back and forth from each form. Today we are doing what we call evaluating logarithms. Our next step after evaluating would be to solve logarithms. So when we evaluate things, especially specifically mathematical concepts, if you're just plugging in values or trying to solve for a piece of it, you will not have an equal sign. So while we are evaluating logarithms, there's a couple of things I wanted to mention to you. Now, when you have a logarithm with base 10, it is called a common log, and it can be written without the base. So you'll notice here I have the notation. A logarithm with base 10 is called a common log, and it can be written without the base. So log, how we would pronounce this would be log base 10 of x, but you can also just say log of x. Notice the little 10 there as the base has completely disappeared. Now, another way that we can do this, so it's kind of understood, if I see like log and I see the number 5 there, it would be log base 10 of 5. That would show up. Now, if we are evaluating logarithms, here are some examples in which we would evaluate. Now, there's a certain thing that you want to ask yourself as you see a problem. If you'll notice right here, it says log base 7 of 49. Now, essentially what the question that is being posed here is it's saying, what power of this base could we raise it to give us something that would be equal to this 49? So what power of 7 is equal to 49. Now, the way that we would write that is we would say 7 to what power gives us 49? And I think all of you are saying right now, oh, it's a 2. So your answer to this would be 2. 7 squared is definitely equal to 49. Now, if you look at the next problem, it says log base 3 of 27. So you would say, what power of 3 to what power will give us a 27? So 3 to what power gives us a 27? I hope that we all know that 3 cubed will give us a 27. So 3 would be your answer here. 3 is the answer. Okay. Our next problem there, you see it says log base 12 of 1. So remember the question that you're asking is, what power of 12 to what power will give us a 1? Now I hope that we all remember that anything to the 0 power will give us 1. So the question mark there would be, 0. So you would put equals 0. Now, the next one I addressed a few minutes ago, this one just basically says log of 100. And you're like, well, where's the base? Well, if you'll remember a few minutes ago when I said if the base was not written, a 10 is understood to be the base. So 10 to what power will give us a 100? So in this case, 10 squared will give us 100. So this would be equal to a 2. Everybody good so far? Okay, let's go to the next one. Here we have 2 as our base. 2 to what power will give us a 64? So if you'll recall, 2 to the 5th gives us a 32, so I believe 2 to the 6th will give us a 64. So 6 would be your answer. Question mark equals 6. Next, now this one looks a little tricky. it says log base of 9 is equal to 1 over 81. So 9 to what power gives us this fraction? Now, if you'll recall, 9 squared gives us a positive 81. I don't know if you remember the idea of if I have anything in the denominator, or if I have a negative exponent, we have to move it to the denominator. So in this case, it would be 1 over 9 squared. So our question mark here would be 9 to the negative 2 is equal to 1 over 81. So negative 2 would be your answer. Now, the next part of logarithms that I'm going to introduce to you is what we call a change of base formula. This is going to be a formula that's going to be really awesome and really helpful whenever you really don't know how to do the problems that we just worked. So it says here, some logarithms are not as easy to evaluate as those that we had just worked. Like we already knew 7 squared was 49. That was kind of easy. 10 squared is 100. Those were kind of easy, but sometimes they get a little tricky looking. So those that look a little tricky and we don't know how to solve, they are going to require what we call the change of base formula. So please make sure you're writing this down. So the change of base formula is like your big friend. It's going to be super, super helpful. So it's going to look like this. You're going to have numbers in the place of B and A. But essentially, this is your general formula. This is a very important idea. Log base B of A is equal to, and essentially this is kind of what you're going to put in your calculator. So you can say the log of the argument. The A is also called argument, or sometimes on the first video I referenced it as the answer, but the log of the argument divided by the log of the base is how we're going to split this up. So we're going to actually use a calculator for this, which is going to be great, and I'm going to show you how to do that. And this is what you call the change of base formula. So we're going to work a couple of these with the change of base formula. So let's start off with one of them. I am not so sure about some of these, so I'm going to write them down, then we'll take a glance at them in Desmos. So if you'll notice here, I have several problems. I am just not sure 16 to what power will give me a 64. If I'm unsure of that, I can go back to the original problem and evaluate it from here. So in my calculator, or on Desmos, I would say log of 64 divided by log of 16. A couple of things that you want to make sure of is you want to make sure if you're using parentheses, you make sure you close the parentheses around the 64 and the 16. You won't evaluate it correctly. Another one right here, if I have the log of 32 divided by the log of 8. Now, this is saying 8 to what power gives us a 32. Okay? We know 8 times 4 gives us 32, but 8 to the first power is 8. 8 to the second power, which is 8 times 8, is 64. So we would know it's going to be a number between the numbers 1 and 2, but a decimal is what it would be. So we're not so sure, so we'll use our calculator in just a minute. Another one we're going to put our calculator to is log of 294 divided by log of 10. We will work these out in just a moment. Here we would say log of 54 divided by log of 2. Essentially, you're just finding the exponent, and in these cases, these 4 cases, you'll find that they probably are going to be equal to something weird, something fraction-like, maybe even a decimal. So that's what we'll do. We'll transition to the computer next. Now, if you will notice here, we have log of 64 and log of 16. So we're going to try to put this in the calculator. So all you have to do here is you have to go to desmos.com, or you can use your Desmos app, which would be perfectly fine. Click on Start Graphing. And then from here, if you'll recall, the problem was log base 16 of 64. So we are going to put that in our calculator as, if you'll notice here, we have to find it. So it's called a function. And you're going to go to miscellaneous. It's going to be this one right here. So log of 64 and then divided by log of 16. Make sure the parentheses are there. And it tells me the answer is 1.5. So the answer to this problem right here, the very top one, would be equals 1.5. So equals 1.5. Here, the next one, log base 8 of 32. 8 to what power gives us a 32? So I'm going to go back to Desmos, and I'm going to do log of 32 divided by log of 8. You'll notice it gives me a decimal here. 1.666666 repeating would be 1 2/3. You can give me the decimal or you can give me the whole number or the fraction if you would like. Our last little video, our last little example there, let's try, oh, I don't know, this one. Log base 10 of 294. Going to go to Desmos and I'm going to say log of the argument divided by log of the base. So I'm going to say log of 294 divided by, didn't do it right. You want to make sure that you choose the function. I didn't try to do a shortcut way. Didn't work out. Log of 294 divided by log 10, I believe it was. And so there, make sure that's in parentheses. I just want to make sure it's the right one. And so there you go, 2.46. So obviously I could not come up with 10 to the 2.468347 equals 294.